In this video, we are going to discuss the decomposition of copper 2 carbonate hydroxide hydrate. This reaction involves decomposition of a hydrate, so we'll need to pull down a crucible to hold our hydrate, as well as a Bunsen burner to help us decompose the hydrate. Lastly, we'll need a balance to record the mass before and after the decomposition reaction in order to find the difference in mass. That difference will tell us what has been liberated from the original hydrate. Before we start, we'll want to record the mass of our crucible in our lab notes just in case. Inside our crucible, we will place 5 grams of copper 2 carbonate hydroxide hydrate and then take the mass of the entire system. Record this in your lab notes. In order to monitor the reaction, we will double-click on the crucible and check the box that says Show Contents. Click OK for it to show contents. Inside the crucible, you should see a green substance which stimulates our hydrate. We'll place the crucible onto the Bunsen burner and turn the heat to low by turning the knob just once. Once the green substance changes color, it should turn into a black powder. That is when you know the reaction has taken place. This may take a few seconds, so watch carefully as to not keep the crucible on the heat for too long. Take notes on all relevant observations in your lab notes. As you'll also notice from the top of the crucible, a gas has escaped. You'll want to remove the crucible from the Bunsen burner and turn it off. Mask the entire system one more time to get the final mass, and record this in your lab notes as well. Lastly, of course, you'll want to clean up and discard any materials in the recycle bin. Next, we will transition into talking about the balanced equation.
Now what the product of this reaction might be, we need to look at the mass lost. We started out with 5 grams of hydrate and ended with 3.327 grams of black powder substance, representing a 0.66 mass ratio. The molar mass of our starting hydrate is 239.136 grams per mole, which means that we're looking for a product that has a molar mass of about 160 or some factor of that number. We know that one of our products is H2O and the other must be a gas, and this article here actually states that when heated, copper 2 carbonate hydroxide hydrate loses water and carbon dioxide to form cupric oxide. This equation can be written as, and we find the molar mass of cupric oxide to be around 80, and since 2 moles of cupric oxide are formed with each mole of reactant, this mass comes out to be around 160 grams per mole reactant, which is parallel to our earlier calculation. Again, we have our equation that is 1 mole of copper 2 carbonate hydroxide hydrate decomposed to form 2 moles of cupric oxide, which is black powder left in the container, 1 mole of CO2, which escapes, and 2 moles of H2O, which also escapes. And here's our citations, and thank you for watching this video.